Good morning, everybody. I hope you had a great last couple days, and I hope that you had some success and some fortune as you were going over these problems of factoring. I know we spent a lot of time kind of looking at quadratic, trinomials, and stuff like that, and even ones that we had to do a little substitution. So hopefully when you looked at the homework and you were faced with other problems that maybe we didn't talk directly about, you still were able to find some success. Anyway, so I'm gonna blast through the homework here real quick, and hopefully as you have yours out, we can take a look at it together. And so here I'm just going to go ahead and start with number 13. I can't remember. I know there's a couple of these we probably got done in class, but it's just worthwhile. Some of these are so fast. So 13, we got this quadratic trinomial. So we're looking for factors of -3 that sum to, and those of course are -1 and +3. So this would be x minus 1 times x plus 3. All right, on number 15, we're looking for factors that multiply together, give me -15, but when I add them, I get +2. And that, of course, would be +5 and -3. So I'd say x plus 5 times x minus 3. Now, hopefully, you realize that you could have those in any order. You could say x minus 3 times x plus 5. That wouldn't make any difference. All right, now we get to this third one, number 17, and this is where all of a sudden we had to pay attention to more than just this last number, but we had to look at this first number too. And so when we did these, we said, well, the 3 times a 5 gives us 15. So we're looking for factors of 15 that sum this -16 in the middle. And that, of course, would be -1 and -15, because it's got to become +15, so they both must be negative. And so what we did then was we split that -16 into those two values. And it didn't matter which way we go. We talked about that you could do the -1 first or the -15 first. It didn't really matter. But what we'd have is we'd have something like 3x squared minus 1x minus 15x plus 5. And maybe you did 3x squared minus 15x minus 1 plus 5, or 1x plus 5. It won't make any difference in the long run. And so then what we said is, well, we're going to factor just this part, and separately we will factor just this part. Okay, this is factor by grouping. So I look at that first two terms, and the only thing I can take out of those is an x. And so I pull that x out, and I'm left with 3x minus 1. And out of the second two terms, the only thing I can take out is a -5. Notice I've got that negative right there, and so I'll tell you just a quick hint is this sign, no matter what it is, always gets factored out. Always. This is how it works. And so I'm going to say we're going to take out a -5. And if I take out a -5, then I'm left with a positive 3x minus 1. Okay? Because a -5 times a -1 would give me that +5 right there. And now I can see I've got the same thing here as I do here. I've got that 3x minus 1. And so just like we said before, we can kind of factor that off to the front or back. Doesn't matter. And we look at what's left. I've got this x minus 5. So I go x minus 5 times 3x minus 1. And that's your final answer. Or you may have gotten 3x minus 1 times x minus 5. But either way, it's the same. Now, on number 19, we looked at this and we saw that this 3x plus 2 shows up in a couple different spots. And my hope was that you could kind of look at this and see this as almost it was a big variable. We talked about the idea of this being z, okay? And I don't know if that really shows up. Doesn't really show up very well here. Let's make that a little bit darker. I could say a z right here and a z right here. And if we looked at that, then really what this would say, we'd go, well, okay, so let's let z, the variable, equal 3x plus 2. Let's just say that that's the case right now. And if that were the case, then if I go to rewrite this, it's going to be z squared plus 8z plus 12. And so all of a sudden this really complicated quadratic with this weird term inside of it became a very basic quadratic where we have to find the factors. Let's change that back to yellow. The factors of 12 that sum 8, and that would be 2 and 6. And so I'd factor this down and I'd get z plus 2 times z plus 6. And then at this point, I would go ahead and factor back in, or I'm sorry, not factor, but substitute back in what z is equal to. So then this would say 3x plus 2 plus 2, okay, because this plus 2 had to show up somewhere. And then times 3x plus 2 plus 6. There we go. And what I can do is I can just kind of simplify that a little bit down. Let's see here. I'll Trying to make a little bit of room for myself. Okay, there we go. And so I can just combine like terms there, and it would finally say 3x plus 4, because 2 and 2 is 4, times 3x plus 8. And that's the factored version. Now you could go ahead and square this binomial, and you could distribute up here, and you could combine it with 12, and then you get something and factor it, and in the end you'll still get this answer. It's just a lot easier to do it this way with a little bit of substitution. All right, now let's see what we got going on here. 21 and 23. 21 is a really simple problem. It says simply x squared minus 25. And x squared minus 25 is what's called the difference of two squares. We have x being squared, and we have something else being squared that gives us that 25. So hopefully you would look at this and kind of in your head you go, well, that's the same thing as x squared minus 5 squared, because 5 squared is 25. And so this is where we call this the difference of two squares. And the difference of two squares always factors into what's called the conjugates. The first term plus the second term times the first term minus the second term. And so when I say that, it would look like this. You go x plus 5 times x minus 5. We would have that for every difference of two squares. If this was x squared minus 9, you'd go, well, that's the same thing as x squared minus 3 squared. So that would be x plus 3 times x minus 3. It's really simple. And these right here are called conjugates, okay? It's really, really simple. And so that factors that way each time. Now, you could also, it would not be a big deal if you wrote x minus 5 times x plus 5. That, of course, wouldn't matter at all. We're just changing the order of our multiplication, and that's no big deal. Okay, now we've got this number 23 that has an 8a cubed minus 1. Okay, now 8a cubed minus 1, I think that's what number 23 is listed as. Let me just double check that real quick. No, I don't know where I got that. That's number 39. Number 23 is what? 49 minus 4z squared. I'm glad I double checked. Okay, so we're going to get rid of this. And so number 23 is supposed to be 49 minus 4z squared. I knew that didn't fit with the other problem, but either way. So then again, this is the difference of two squares. You go 49 is what? That's 7 squared minus, and what's 4z squared? What's the square root of that? Well, it's 2z squared. Now, it's okay if you don't do this step right here. It's not going to hurt my feelings, but I'm just trying to make it a little bit easier so you can see that number inside. And I break that up into the conjugates, and I say 7 plus 2z times 7 minus 2z. And all done. Okay? And if you can kind of fast track that, and maybe you have the kind of the mental capability of going straight from here to here, I'm okay with that. I'm just trying to help everybody catch on to where I'm coming up with these numbers. All right. Next, these next two, it said specifically in the directions, hey, factor these perfect squares. And that's what these are. These are perfect squares. Now, we didn't talk about that at all on Tuesday, and that's okay, because you should still be able to factor these. I mean, everyone in the class should be able to go, well, what's factors of 25 that add up to be 10? Well, 5 and 5, okay? Or what are factors of 36 that add up to be negative 12? And that would be negative 6 and negative 6. Now, these can get more complicated, but basically a perfect square means what you're doing is you can always check to see if it's a perfect square by looking and going, is this something squared, and is this something squared? And clearly that is. We got x squared and we've got 5 squared. And then if I multiply this and then double it, do I get this? And the answer is yes. And so then what this can factor down to always will just be these two values added up, quantity squared. Okay, that's called a perfect square. Now, you might go, wow, that was really crazy. And so you might see and go, well, factors of 25 that add up to be 10. Well, that was 5 and 5. So you looked at it like this. Said, well, that's x plus 5 times x plus 5. And that's true, which is the same thing as x plus 5 squared. Now, I know we didn't specifically talk about these perfect squares, but here's just a real basic one. And so hopefully you can see how that works. They could get more complicated where we could have something that says like 4x squared minus 24x plus 9. And again, our question would be, is this something here? Is that something squared? And is this something squared? And then for starters, it is. This is 2x squared. This is 3 squared. And then if I take those two values, well, let's change this problem up a little bit. Make it say 12x. If I take those two values and say 2x times 3, or this could also be a negative 3, 2x times negative 3, that gives me negative 6. And if I double that, I'd get negative 12. So this whole thing right here is a perfect square, meaning it would factor down to 2x minus 3 squared. And you could go through all of the factor by grouping and you'd get the same answer. This is just a little shortcut. Okay? Factor by grouping would get you this exact same answer. This just gives us a shortcut. All right. Well, let's look at these other ones. There we go. Okay. All right, so we're looking at number 31. Again, perfect square. All right, this is something squared. This is something squared. This would be z being squared. This is 6 being squared, or it could be a negative 6. And negative 6 times z doubled is negative 12. So I could go, well, this must be z minus 6 squared. And even if you didn't do it that way, you go, well, what are the factors of 36 that sum negative 12? And the answer is negative 6 and negative 6. So maybe you saw it as z minus 6 times z minus 6, which is z minus 6 squared, which is exactly what I have here because math is true. All right. Now, let's get into probably what was the most challenging thing that we did not talk about. Now, just because we didn't talk about it doesn't mean that you can't do it. There's a page, it's a page right before the homework in your book. There's a blue box that shows the formula for this. And this is called, we look at these two next, and these are called, this is the sum of two cubes, and this is the difference of two cubes. And so I want to talk about those real quick. Okay, the sum of two cubes. The sum of two cubes, there's this basic formula. It says, hey, if you have something cubed plus something else cubed, every time this factors into the first one added to the second one times the first one squared minus the two of them times each other plus the second one squared. And if you have something cubed minus something cubed, that will always factor into the first one minus the second one times the first one squared plus the product of the two of them plus the second one squared. Now, again, that might sound like I just blew through that super fast. And I did, because this is just a formula out of your book. Now, it's worth recognizing, it's worth knowing, but one of these things, sometimes it's hard to remember. So what I want to encourage you is, as I looked at this, I remember being a young person trying to understand this, really, ultimately, there's not a whole lot to remember. All you got to remember is you got a, b, a squared, ab, and b squared. That's consistent on both of those. A, b, a squared, a times b, b squared. Now the signs between them are a little bit different, but if you can just remember that it's always, every time, it's a and a b and an a squared, ab, and b squared. I can help you remember the signs. You just have to remember that part, and that's easy, okay? So whether it be the sum of two cubes or the difference of two cubes, it's always just going to be a, b, a squared, ab, b squared. All right, so now let's talk about the signs. The easiest way I can think about to look at the signs is, first of all, whatever the first sign is here in the original shows up in that first term. So see, right here, this was a minus, that shows up right here. Now, this is going to sound a little complicated, but the other thing I can tell you is there's always only going to be one minus sign. So if it didn't show up here, then it shows up next. If it did show up here, then the other two have to be plus because there's always only one minus sign. So this first one, this first box right here, this always matches the sign here. Notice we have A minus B, so that matches the minus in the middle. There's always only one subtraction. So if it showed up here at the first one, then these other two have got to be addition. But if it didn't show up here in the first one, if that was addition, then it's always going to be the next one. And so this is the same thing over and over. And so just with a little bit of review, hopefully you can look at that and go, man, I can remember that. That's not too crazy, okay? That you would be able to go, well, let's try that again. So if I had x cubed plus y cubed, you go, well, what would that equal? Well, I know that I'd have x, y, x squared, x times y, y squared. Let's say I don't even remember any signs. And it could be x cubed minus y cubed. And it would still be x, y, x squared, x times y, y squared. And so how do I remember the signs? Well, the first one always matches what I have here. So if this is a plus, boom, plus. If this is a minus, it's minus. And the second thing I've got to know is that there's always only one minus sign. So if it didn't happen in this first binomial, it's going to show up right here. And then the last one would have to be plus. Like I said, there's only one minus sign. So if it showed up here, then these other two have got to be plus, plus. And it's that simple. All right. So now let's take that idea and let's apply it to these two problems, number 37 and 38. Okay. So again, we got to go back and go, okay, so what are these? This is x cubed. So that is literally x being cubed plus 3 being cubed. All right. And we take that and we use that with this formula. This is the sum of two cubes, so it's going to look like this. Say, all right, so what is it going to be? It's going to be x, 3, x squared, 3x, and 3 squared, which is 9. Okay? And then we go, well, what are the signs? Well, the first one always matches whatever sign we have. Oops. So the fact that this is plus, I put a plus right here. We said there's always only one minus sign. If it doesn't show up first, it shows up next. And then this would have to be plus. And it's that simple. Okay? You can't make this hard. The only maybe in between step I could have shown, if I said, well, that's the final, is I would have said, well, you're going to start with x, 3, x squared, 3x, and 3 squared. I go, well, and this top one was a plus, so therefore this has got to be plus, and minus is next, and then plus. And then all I would do is turn the 3 squared into that 9. It's that simple. I mean, this just isn't hard. So let's look at this next one. This is the difference of two cubes. So this is literally y being cubed minus 4 being cubed. 4 times 4 is 16, times 4 is 64. So again, this would factor down to y and 4 are going to be in that first grouping, and then you're going to have y squared, you're going to have 4 times y, you're going to have 4 squared. And to remember the signs, we always remember whatever's here shows up in that first one. So that means this is going to be minus. And there's always only one minus, so therefore this has to be plus, plus. And I could simplify it a little bit and say y minus 4 times y squared plus 4y plus 16. And that's it. All right. These next two, again, we didn't directly talk about these, but oh my, I hope you tried them because these are too easy. All these is it's just like these problems that we had back here where we had, it's really just this problem, where we had a trinomial with that coefficient on the front, and we had to break it down into 4 terms. Except these are already broken into 4 terms. See, 1, 2, 3, 4. 1, 2, 3, 4. So all we do is factor by grouping. It's so simple. So we go, okay, let's factor those first two, these two right here. And the most I can take out of those is an x squared, leaving me with x plus 4. Out of the next two, only thing I take out is 1, leaving me with x plus 4. So then I have x squared plus 1 times x plus 4. That's it. For number 47, you go, well, let's factor these two, and let's factor these two. So to factor those first two, the most I can take out is an x squared, leaving me with 2x plus 1. And then the thing I can take out of the next one, remember I said last time, I did say this, that whatever sign is here is going to get factored out. So that's why this is a minus sign. So I'm going to factor out a negative 3, leaving me with a positive 2x plus 1. So then I have x squared minus 3 times 2x plus 1. And it's that easy. Okay, now, this last set of problems, specifically, there was very vague directions. It said, hey, just factor these completely. And you have no idea if these are just a binomial that factors a little bit. Maybe it's just a trinomial that only factors a little bit. Maybe it's a quadratic that factors out real nicely. Maybe it's a difference of 2 cubes. Maybe it's not. And so you've got to actually just kind of be smart enough and sharp enough to look at each situation differently and go, what can I factor? So this first one, you might be tempted to go, oh, check it out. It must be something about the sum of 2 cubes. But it's not. Here, you just got to say, well, what can I take out of both of these? Well, I've got 12x cubed and 18x. So if I think about that in a real elementary viewpoint, I would go, well, this is the same thing as 6 times 2 times x times x times x. Whereas this other one is the same thing as 6 times 3 times x. And all your job is to do is to go, what do they have in common? This has got a 6 and an x, and this has got a 6 and an x. And so that's what I can factor out. Out on the front, it would be 6x. And whatever is left right here, 2x squared. And whatever's left right here, plus 3. And that's as far as I can take it. That's completely factored. All right, let's look at the next one. Same thing. You could look at this and say, well, this is 3 times 2 times y times y times y times y minus 3 times 5 times y times y times y. Well, what do they both have? This has got a 3 and 3 y's, and this one has a 3 and 3 y's. Now, the first one had a 4th y, but the second one didn't. So I could take out 3y cubed, and what would that leave? 2y in the first one minus 5. And that's it. That's completely factored. And so you might have thought that this was going to go even further than that, but it doesn't. That's as far as it goes. Okay, now let's look at the next two. They're just these basic trinomials, 63 and 65. So the first one, we say, well, what are the factors of negative 8? The sum to be negative 2? Easy. Negative 4 and positive 2. So you say x minus 4 times x plus 2. Hopefully you did that right. Next one, we say, well, what are the factors of positive 15 that sum negative 8? Easy. Negative 3 and, oops, I wrote x when this is a y. So we say y minus 3 and y minus 5. And it doesn't matter if you have y minus 5 times y minus 3. It's the same thing. All right, these next two. All right, this is we step it up a little bit. We've got a leading coefficient besides 1, and so that makes this a little bit more interesting. So on the first one, we say 2 times 3. Well, that gives us 6. Factors of 6 that sum that 5, well, that would be 3 and 2. So we split it into those. And so you can write it either. You can split it, make the 3 go first or the 2 go first. Doesn't matter. So I might say 2x squared plus 3x plus 2x plus 3. I say, well, what can I take out of those first two terms? The only thing I can take out is an x, leaving me with 2x plus 3. Next thing, the only thing I take out is a 1, leaving me with 2x plus 3. So then I have x plus 1 times 2x plus 3. Done. Completely factored. Now this next one, I don't know if you see how fun and interesting this can be, but if our habit is to multiply that first term times the last term, you go, oh, I got it. It's just 9 times 45, and everybody knows that 9 times 45 is negative 405. And so what are the factors of negative 405 that sum negative 36? Oh my goodness, if that doesn't make you want to throw up, nothing will. So what you were supposed to see is right from the get-go, you can make this problem so much easier because 9, negative 36, and negative 45 are all have the factor 9 in them. So I can pull a 9 out and make this say x squared, and negative 36 divided by 9 is 4, and negative 45 divided by 9 is 5. And oh man, doesn't that look a whole lot easier? So I could go, well, what are the factors of -5 that sum -4? And that answer would be -5 and +1. So I have 9 times x plus 1 times x minus 5. And that's it. And man, you didn't think that was going to go out so easy because it seemed really complicated and scary up here. All right. And now the last one. All right. We look at this and we say, okay, I've got this 6x squared minus 5x minus 6. So again, look at the first and last terms, 6 and -6. That gives us -36. What are the factors of -36 that are going to add up to be -5? This could be -9 and +4. So I split that into those two values and say 6x squared minus 9x plus 4x minus 6. I go ahead and factor these first two terms, and I say, well, I can take out a 3x, leaving me with 2x minus 3. And out of these second two terms, I can take out a 2. If I take out a 2, I'm left with 2x minus 3. And now I have 3x plus 2 times 2x minus 3. All right, and there you go. That is all of the homework. I hope that made sense. I hope we got your questions answered, and I hope I didn't make too many mistakes. All right, get ready for the lesson.